topic is big data-driven Internet of Things towards environmental sustainability and intelligence. I'm affiliated with China and Chile. Yeah, here is the outline. Basically, I would like to talk about the Internet of Things and the big data, green issues, and big data, the relation big data and the green, and ICT with certain SDG, and the big data with the Internet of Things, and yeah, green Internet of Things and with the intelligence. This conference is about green chemistry, but my area is more close to information technology. I try to talk about the relevant issues. And I assume the relevant issue is the environment. Yeah, first, the Internet of Things is the term. This term talk about the entities could be different in the device, could be machines, yeah, but connect together through a network. And the Internet of Things also can have different names, CPS, machine to machine, device to device, sensors, RFID, MEMS. This it's based on different context. And the big data, the term big data is coming start from early 2000. Now later on, they have also different discussions. Even up to now, we do not have unique definition what is big data. But one thing is one feature is consistent. It's about the volume. Typically, they consider the volume is high, but the level of the high level is also determined by the context. Typically, this is a big data systems about the lower layer, including storage, processing layer, and the service layer, also called application layer. In information technology area, many people talk about the green as relevant to energy. But what is green? This is a general definition we published in 2016. Actually, we have this definition in 2011 in different oral speech. Basically, they have two terms. One term is environmental, economic, socially, technically sustainable. The other is the same adjectives with friendly. This means that the green is considered both sustainable and friendly. We have the one feature is consistent. It's about the volume. Typically, they consider the volume is in 2016, we have 2 papers talk about big data and relevance, big data and the green challenge. And this paper, this is the first paper. The first paper talk about how the green issue in big data system. This is the bit outline of the paper. In the paper, we also propose a new concept about energy efficiency. Energy efficiency was discussed in 1996. There's a general definition: output and input. Typically, the input is, or you can reverse the numerator denominator. Yeah. And the general definition also can consider have a number of different variant. Yeah, this definition about energy efficiency typically used in ICT area, information technology area, and the above term is a information base. The bottom term is energy. Our special proposal is have a term called the important factor. And the important factor means the information base is not equivalent. Typically, people consider the information base as equivalent. But our proposal, we can consider, and the difference is depend on how important in current use of the bits. And the beta was proposed in by Pat, 1996. It's about the quality of energy. We also define this one we call the effective energy efficiency. And we also define the effective resource efficiency. The difference between the first one and the bottom term is resource. We also have the important factor in the above term. Another paper we talk about this general discussion is about the big data towards green applications. This one is not about big data itself, but use big data as a tool, tools to achieve green objectives. And here is the outline of the brief outline and what we discussed. We discussed environmental issues. We discussed energy efficiency, energy management, or we discussed the general sustainability objectives. Another discussion relevant environment is ICT for Sustainable Development Goals. Sustainable Development Goals is defined by United Nations in 2015. This is a general discussion. Since our today our talk about the Internet of Things. The Internet of Things is a subset of ICT. And in the paper, we partition totally 17 SDG are the 3 categories. One category is called social sustainability. We are then the SDG 5 achieve gender equality, and SDG 10 economic equality. And also SDG 11, 12, 16, 17. Yeah, the second is environment. Environment including nature resources and environmental conserve or environmental conservation. This one is really relevant to our conference. This is a general picture how ICT can help environmental sustainability, including the data collection, data processing, and the source of data. Yeah, this is a general this is a general picture of the SDG. And we mentioned the 17 SDG. Yeah, a sequence of the slides I didn't move properly. Yeah, and actually these 2 slides should be discussed earlier. Yeah, this is a 3 category we proposed. Before these categories, nobody have this kind of classification of the 17 SDG. We proposed the first version how to categorize the total 17 SDG. Yeah, and there's a third category, the economic sustainability. Yeah, including the poverty, agriculture, and education, and also economic growth and industrialization and foster innovation. Another term, right? We want to talk about the environmental intelligence. We found that environmental intelligence is not brand new term. This even started in last century. And actually this one is earlier, environmental intelligence is earlier. John Touch have a talk in 1996 talk about the environmental and the intelligence agenda. Their contest about the police, the policemen have a new new roles, not only talk about transportation or criminal or something. Also, the policeman also can surveillance of environment. Another term called ambient intelligence. Ambient intelligence, the first we found the in the reference in around 1998. Ambient intelligence seems a narrower term than environmental intelligence. Talk about the context, talk about the device, the electronic device, how to respond to the surround environment. Or even in environmental intelligence, the term start for some years. But in that period, even the big data, the topic just start. Now we talk about the environmental intelligence, have different meaning inside, because of, especially in recent years, artificial intelligence, relevant technologies, algorithms has been developed quite fast and with many advances in new progress. Under this context, environmental intelligence haven't have sufficient discuss and research investigations. That's the meaning and the importance why we would like talk environmental intelligence now. Yeah, we actually why we talk about the Internet of Things, big data, and environmental intelligence, because the intelligence just one of the way to use data. One of the way we talk about big data, but the big data can process by intelligence, also can be processed in some other way. For example, statistics. Yeah, and the intelligence is one of the way to use the data. And the data, if we want to discuss, we want to discuss the sources, generation, and collection. And our conference is green chemistry. We believe the green chemistry is one way to collect data. Yeah, in some in different context, you will have different kind of the data. Could be analyzed, could be have to divulge more knowledge from the information. Yeah, we discussed the context-aware. Context-aware have two terms in ICT area. One called context-aware computing. Context-aware computing is greater than context-aware communications. Yeah, we define context-aware networking and communication in a special issue we proposed, published in 2014. this is another way to collect data. Cross sensing, participatory sensing. Yeah, basic idea to get the information from a number of nodes, could be mobile or non-mobile, a number of nodes, and to then to get processing. And remote sensing. Remote sensing use satellite, use low Earth orbits, use UAV. Yeah, and remote sensing also is an important way to get different is one is considered also Internet of Things, and to get the information, get data from the environment. After we get data, we should have the data storage and the data communications. Here I have some relevant works. For example, the local storage, caching in the edge computing. Also the centralized Hadoop centralized storage. Here I have another way is about big data communications. After we get the data, we need the communication for the storage, also for the processing. This also the challenge for if we are this relevant to the environment. We have many nodes to collect the data, and how we can promptly to communicate those data together for storage and processing. Yeah, for the Green Internet of Things, in 2011, we have the paper called the power saving machine-to-machine communication. And under the context of cellular networks, we discuss the model. Actually, we proposed a new protocol stack to save the power during the communications. And the node is a machine. That's why it's the Internet of Things. Here are some details about the how do we discuss and propose the new stack. They have in the cellular networks have access short-term. You can consider as access layer, non-access. Access means you have multiple users together. You have competition, and non-access means no competitions. Will through the communication layer. Yeah, here is a new state we proposed in the stack, and this specially proposed for machine. Previously, the stack is proposed for human, and the difference from human and machine. Typically, human cannot accept delays, but the machine are different. Machine, in this case, we change the model, change the stack to facilitate the machine in the stack, machine communication in the stack. Another proposal called group ID. We have at least two proposals in the paper. Group ID means the device is communicate grouply instead of just a single. This also different from a human. Typically, human very hard to grouply several human together, but the machine we can do that. Yeah, this is some performance. Another example. This one is relevant to intelligence because we use reservoir computing. Reservoir computing is a kind of machine learning. It's a kind of here the environment is talk about the smart grid, the electronic smart power grid. In this environment, we try to ensure the reliability to protect the false data injections. Since some other words agent try to attack or try to get the information or illegally use the electricity from the power network, power grid. Yeah, we try to find those attack and try to protect the security, the safety of the network. Yeah, those the technology we used and we proposed. Especially we use reservoir computing in the context. Yeah, this is a basic idea or illustration about the reservoir computing. Reservoir computing in the middle have a pool. The pool have not permanently connected the node, the neural node. Due to the connection is not permanently connected, it's randomly connected. It is possible to save energy. Yeah, this performance, this performance the top one is the top one is our proposal. The lower one is a multi-layer perception. One the SVM support vector machine, two machine learning algorithms. Our proposal is very robust, depend on the attack load. This 0.1 and 1, this is horizontal axis is the load of attack. Our proposal is very robust to the attack load. The rest two algorithms is sensitive to the attack load. The problem is sensitive to attack load. Yeah, and now we finish the talk and welcome questions.